Okay, let's have a quick look at electron configuration. First thing you need to remember is that the electrons are orbiting outside the nucleus. There's our positively charged nucleus, and the electrons are in shells. We might have an electron here, we might have one here, might have one here, etc. So the electron configuration is a way to show where the electrons are actually found. Now the thing is, they will first be found in the first shell. Okay? Electrons occupy the shell with the least amount of energy possible first. Well, remember the shells correspond to energy levels, right? Bohr talked about the shells and the energy levels. If an electron has a certain amount of energy, it will be in a shell. If it has more energy, it's in a shell further out, etc. So we start by filling the first shell, and then we move out to the second shell, and then out to the third shell, etc. So, in terms of the electron configuration, let's talk about lithium as our first example. Okay, so lithium is number 3 on the periodic table. If you're not sure about lithium, you find it on the periodic table. Here it is, and sure enough, it's position 3. Now that position 3, that's its atomic number. Lithium has an atomic number of 3, which of course is defined as the number of protons. So lithium at number 3 will have 3 protons. Now the thing about atoms is that they're neutral because they happen to have the same number of negatively charged electrons as they do as the positively charged protons. So 3 protons, it will also have 3 electrons. Okay, how do we put those electrons in the shells? Well, we start with the first shell. Now the first shell has a maximum, well any shell I should say, has a maximum number of electrons. It's given by 2n squared. Now Bohr gave us this, so 2n squared, where n is the shell number. So how many electrons can fit into the first shell? Well, for the first shell we have 2 times 1 squared, because the first shell. Well, 1 squared is 1 times 2, so we can have a maximum of 2 electrons in that first shell. In the second shell, we're going to have 2 times 2 for the second shell, but then that's squared, so 2 squared is 4, and times 2 gives us 8 electrons maximum in the second shell. Doesn't mean you're actually going to have 8 electrons, but if you were to fill up that second shell, it would take 8 electrons before it was full. And similarly, for the third shell, 2 times 3 squared, so that can take 2 times 9, so 18 electrons would fill up that third shell. And then we do the same for the other shells, right? So this 2n squared, that just tells us how many electrons could there possibly be in any particular shell. So back to our lithium. Right, so we know that we have 3 electrons because there are 3 protons and atom's neutral. Now, we put those electrons into the shells starting with the first shell, but we can't put all 3 there because the first shell could only take 2. So, all right, let's put those 2 electrons. Then we put a comma. We separate the shells with a comma. So we've put 2 electrons in, we have 1 more. Well, the next shell can take 8, so it's really not going to be an issue just putting 1 more in there, is it? So that is what we call the electron configuration, or the electron arrangement for lithium. Its electron arrangement is 2, 1. Let's choose another one. Right, what one shall we do? How about this one right here, nitrogen? Okay, so nitrogen is number 7 on the periodic table. Its atomic number is 7. It will have 7 protons. That's lovely. We don't really care about the number of protons. We're after the number of electrons. But luckily for us, we know that if it has 7 protons, it's also going to have 7 electrons. Okay, let's put those electrons into their shells. We have to start with the first shell. It can't take all 7. It can only take 2. And then we can move to the next shell. Now the next shell can take another 8 electrons, but guess what? I've only got 5 more, so we'll easily fit those 5. So there we have the electron arrangement, or the electron configuration for nitrogen. Let's choose another example. Let's go a bit bigger now. How about silicon? Here it is here. Silicon is number 14. Okay, so let's do silicon. Si for silicon, it's position 14 on the table. It's got 14 protons. It will also have 14 electrons. Let's put them into the shells. Well, the first shell can take 2. Lovely. I've still got 12 more. Now the second shell is not going to fit all of those 12. I can't put them all into the second shell because it will only take 8. So let's put those 8 there. That shell is now full. I have to move to the next shell. So another comma to separate shells. Now, I've used 10 all up, right? 2 from the first shell, 8 from the second shell, I've used 10 electrons, I still have 4 more. Well, we said that the third shell can take 18 electrons. So 4, not a problem. They will easily fit there. That is the electron arrangement for silicon. Let's do another one, potassium. Now, if you look on the periodic table, you will find potassium here, and you'll note that it's number 19. Now, I chose potassium because potassium and calcium we do something a little bit trendy with. So here's what we would want to do with potassium. We would say, okay, potassium is number 19, 2 electrons into the first shell. I still have 17 more. 8 of those can fit into the second shell. Okay, cool. I still have 9 more electrons because I've used 10, I've still got 9. Now that third shell can fit 18. So another 9, well, that's not going to be a problem, is it? There we go. Except no, there we don't go. That's actually wrong. The catch is, for the 19th and 20th electrons, in fact, let's jot this down, 19th, so we're talking potassium, and 20th electrons, so we're talking calcium, right, 19th and 20th electrons, they actually go into the fourth shell, all right? That's just a little catch you need to remember. We start the fourth shell even though the third shell isn't full. Okay, so we go back to potassium here. We don't just put all those 9 there. We actually put 8. So we go up to 288. And then we've got one more. The 19th electron actually goes into the fourth shell. So 2881. Right? And if we were doing calcium at number 20, that would be 2882. Okay, that 19th and 20th electrons actually go into the fourth shell. That third shell was not full. Okay, we know that the third shell can actually take 18 electrons. So having 8 in there, well, it's definitely not full, but number 19, number 20, we put into the fourth shell. The thing is, only the 19th and 20th. After that, we would actually come back and fill up the third shell up to what it could go. Right, let's choose another one. Let's do cobalt. Cobalt is number 27. So let's write the electron configuration for cobalt. All right, CO for cobalt is number 27. That means it will have 27 protons because that's its atomic number, but we know that it's neutral. It will also have 27 electrons. So we've got 27 electrons to put into shells. Right, let's go. 2 in the first shell. I've still got 25 left. 8 in the next shell. Okay, now the next shell can take 18, but we're not doing that. We're going to put 8. And then the 19th and 20th start the fourth shell. Okay, so there we go, 2882. That's the configuration of calcium, number 20. But then higher than that, we think to ourselves, wait, that third shell wasn't full. And we come back and we fill it up, right? So 2882 gets you as far as number 20. I have another 7 electrons, so those 7 electrons go into that third shell, right? So we do come back to fill up that third shell, up to the 18 that it can take. We just started the fourth shell a little bit early, right? Now, the whole, why would we do that? Well, in terms of shells, first, second, third, fourth, fifth, etc., the shells, remember, are to do with the amount of energy, right? More energy equals a shell further out. So like the first shell, hey, go away you. The first shell, low energy. The second shell, higher energy. The third shell, even higher energy. The fourth shell, even higher energy. But wait, what did you notice? Yeah, there's a bit of overlap between the third and fourth shell, right, in terms of the energy level there. So that overlap manifests itself into the 19th and 20th electrons start the fourth shell, and then we come back and finish that third shell. So I had another 7 electrons. I come back and I put them in there, and that 8 is no longer an 8 because I'm going to add my 7 there and call it 15. Okay, so the electron arrangement of cobalt is actually 28152. Okay, so we put the electrons into the shells in order from the first one out, but remember number 19 and number 20, they go into the fourth shell, So just for potassium and calcium, we start the fourth shell, and for the next 10 elements, we actually come back and fill up the third shell up to the 18 that it could take. So there you go. That's electron arrangement or electron configuration.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.